Hello, I am Isam Tansimul Haq from Team Rush. My ID is 17301095. There are three libraries determined and .h is a header file. LM35 pulse sensor playground, these are the sensors names. We define use Arduino interrupt, its work in a true condition and works in a loop. Software.serial.h is used for differentiate between two terminals. We define first pin LM35 which is goes to A1. LM35 goes through with A1 and will take input from A0. LED blink on pin 13. We determine frequency in threshold. Then we determine the pulse sensor library. Software serial blue. In this part we get in frequency from pin 11 and pin 12. We set input pulse wire LED 13 and threshold. In void loop part serial dot begin convert Celsius, then convert it into Fahrenheit, then convert it into Kelvin, and then wait 500 milliseconds. Pulse, pulse sensor plus count minute, then count second, and then count delay. After counting all this data, then we give then if we get the data, then we will print, otherwise it will not.
I am Robin. My ID is 1730110. As you can see, this is our Proteus circuit for our project. We use ASB1 as heartbeat sensor to measure the heartbeat. We have used LM35 sensor to measure the temperature and P as our pulse sensor. Here we have our Arduino UNO. We have two virtual terminal and two COM port. One is for BPM and other is for temperature. Mm, this COM port is used to send the data or result uh, in LabVIEW. For COM port 3, RxD pin is connected to Arduino RxD pin, and TXD pin is connected to Arduino TXD pin and all the pin of virtual terminal. For BPM port pin 162 is connected to Arduino pin 11 and TXD RTS CTS pin of virtual terminal. Pin 3 is connected to Arduino pin 12 and RxD of virtual terminal. Heartbeat sensor is connected to Arduino A0 pin. Using RB1, we can sense the heart, and also using LM35, we can sense the temperature. Pulse sensor will blink after a certain time and do the process repeatedly. On the simulation, we can see the results in our virtual terminal. The result is shown in the terminal. Here is the result.
Assalamu alaikum. My name is Muhammad Rahan Rahman, and in the third segment of our presentation, I will talk about the LabVIEW interface. And my ID is 181011169. So before I start my part of the presentation, let me go back to our presentation. So as you can see that we have a two COM ports which is taking inputs from the two different terminals, and these terminals have the same baud rates, but we have specified them with the help of the software serial command. So now as we go back to the front end of our LabVIEW interface, we can see that we have two COM pin connectors with we have a BPM mirrors, temperature indicators, and two charts, which is amplitude versus time charts, and we have a two different data table for two different data sets. So if we go to the block diagram, we can see that we have a two COM pin connectors for two types of data reading, and we have a clear and open elements which is connecting to our main loop, and each of them is connecting to our two reading elements and one buffer latch for each of them. And we also have error controlling for uh, two of the inputs, and this reading is also connecting to the loop, and this whole loop is in the false state and with the estimated waiting time of 500 milliseconds. So from the reading of the temperature, what we can see that it is taking the data from the components and it is sending the data to our temperature indicators and the temperature graph, and is also sending the data to our append array. And we are also taking the IDs for our this project, and this append array is sending data to our array array index, and this append index is with the each shifting which is connecting to our loop is sending the data to the temperature table. Same going with our pulse rate. Taking the pulse rate, it's giving the data to the graph and the meters which we have shown in the front of the block with the front of the lab view, and then we're sending data to the append array. And as we have date and time in here, so we are converting it with the help of the uh, string conversion elements, and then we are taking the data to our array index, and this one which the shifting is pushing the data to the push table. And so thank you very much. This is my part of the presentation. Now my friend Tamanna will take from here.
Hello, Assalamualaikum. I'm Tamanna Hussain, a member of Group Rust. I'll be demonstrating you how the BPM and temperature monitoring using pulse sensor and LM35 works. This is our heartbeat sensor pulse sensor, and this is our LM35. Pulse rate is detected using the pulse sensor and shows the reading in beats per minute, whereas LM35 is used to detect the temperature using IR sensing method. As you can see, we have two components, two terminals. Therefore, we take two inputs and we have two tables as well. The input of the temperature sensor is connected to pin A1 and the input of the pulse sensor is connected to pin A0 of the Arduino Uno. We take two inputs from the two terminal and send them to the temperature and pulse rate graph, which is then pushed to temperature table and pulse rate table, where we can see the data in physical form. As in BPM pin, we have taken port 1, so we take port 2 here, and since port 3 is taken here, we take port 4 here. Now, if we run them, we will get virtual data here and physical data over here. There will be a big delay since the timing of both of them doesn't match. So we get our physical data over here. We can also increase or decrease the beat here and increase or decrease the temperature over here. So this is it for today. Thank you.